Hey guys, what's up? It's Eric with Advanced Level Automotive. Welcome back to the channel. Today, we've got this 2008 Saturn Vue. It's got the 4-cylinder Ecotec engine. Customer complaint with this one is that the check engine light is on. Customer also states that whenever he goes to do a hard acceleration to get around somebody, the check engine light will flash. Now, the customer did say that he took it to a mechanic shop. They checked it out. They sold him a spark plug job. They replaced the spark plugs, but it still did not get rid of the check engine light. Anyways, at that point, he decided to bring it to me. He wanted me to check it out. So now that we have the vehicle here, let's go ahead and get started. Okay guys, so first things first, let's get inside the vehicle. I've got the key right here. I'm gonna stick it into the ignition and we are going to verify the complaint. So turn the ignition on. I'm gonna start the vehicle up. If you pay attention, the check engine light's located right over here. And as you can see, it stays illuminated. So we definitely have a problem. There's our check engine light right there. You guys already know what the next step is. Let's go ahead and get the scan tool. All right guys, so we've got the scan tool connected. I'm using the Autel MaxiSys. We're gonna go into GM. Of course, this is a Saturn. That is a GM product. Let's go ahead and do automatic selection. Read the VIN number. Let's go ahead and hit OK. This one's got manual HVAC. And as you can see here, scan tool has identified the vehicle, 2008 Saturn Vue. Let's go ahead and hit yes. Let's go over to diagnosis. Let's pick the control unit, engine control module, and let's look for trouble codes. Read codes. All right guys, so here's our trouble codes. Starting at the top, see we have a P0171, fuel trim system lean. Looking at the next one right here, we have a P0010. It's gonna be intake camshaft position, actuator solenoid control circuit. This code right here is a real common code you'll find on these engines. That's gonna be a real important one. Moving down to the next one, you'll see a P0300. It's going to be engine misfire detected. Now, it's not specific for any cylinder. It's just telling us engine misfire detected. That's going to be a random cylinder misfire. Next up, we're looking at a P0455. Evaporative emission system large leak detected. So we have a large leak code. Now moving to the next one, we have a P0496. That's also going to be an EVAP code. We're looking at EVAP system flow during non-purge. That, of course, is going to be a real important code. And in fact, this code may be the reason that this code is set. Anytime we have a code P0496 and it's showing that we have system flow during non-purge, that's an indication that we have a sticking purge valve. And of course, if our purge valve is stuck open, we're not going to be able to seal the EVAP system during testing, and you're also going to set a leak code. So keeping in mind that this code here may be the reason that we see this code here. Okay, so looking at this and trying to figure out what direction we want to go in, we need to keep in mind that it looks like we have multiple problems here. So at this point, I think it would be wise for us to try to stop and try to figure out which one of these codes may be related to each other. Again, we already know that this EVAP leak code is probably related to this EVAP system flow during non-purge code. But if we scroll back up and we take a look at what other codes we have, again, we have the P0171 fuel trim system lean. It is possible that this code can be set because of that purge valve. I have seen instances where stuck open purge valves can cause lean conditions. Now, is that to say that these codes are related? I really don't know at the moment. We need to do some checking. Now, if we look at the code below it, this intake camshaft position actuator solenoid control circuit, again, like I told you guys, this is a real common code. We see them on a lot of these Ecotec engines, and for the most part, about 90% of the time, it just needs an actuator solenoid. Now, of course, you need to check and make sure that the engine oil level is correct. And as long as that's good, there's a good chance that you probably need that solenoid. Now, what I can tell you from experience is this code, P0010, can cause some serious drivability issues. I have seen instances where this solenoid gets stuck and it causes the engine to run really rough, and that can possibly set random misfire codes. So if you ask me whether or not it's possible that these two codes could be related, I think there's a really good chance that they are. Again, I'm not 100% sure about that. We still need to do our checks, but like I said, there is a good chance. Anyways, now that we've looked at the codes, let's go ahead and check out some live data. Okay, so I'm gonna go ahead and click on live data. Now, the first thing I wanna go straight for is going to be the fuel trim values. Let me just go ahead and highlight these. And then we'll also pick the loop status. Now let's just go ahead and focus on these. Okay guys, so here we have the 3 data PIDs that we're gonna focus on. Again, we have a P0171, which means we have a lean condition. And whenever we have a lean condition, the first thing we want to do is take a look at the fuel trims. Now, as you can see up here, I have the short-term and the long-term fuel trims. And then if you look up at the top, you'll see that we have the loop status, and our loop status at the moment is closed. So again, taking a look at the fuel trims, you'll see that the long-term fuel trim sitting somewhere around 28. Now I'm pretty sure a lot of you guys know what the next step is. Of course, whenever we have a lean condition like this, we want to try to figure out what type of lean condition do we have. Do we have some type of vacuum leak, or do we have some type of fueling issue? And for the people who don't know, the easiest way to check that is for us to raise the RPM, hold it steady somewhere around 3,000, and check to see whether or not these fuel trims get better or do they get worse. So that's going to be our next check. Okay guys, so as you can see, we have the scan tool on the steering wheel, and if you look right over here, you'll see the tachometer. Now what I'm going to do is I'm going to raise the RPM. I'm going to hold it somewhere around 3,000, and I want you guys to watch for the fuel trim numbers. We want to see, do these numbers get better or do they get worse? Now when I say better, what I mean is that these fuel trim numbers are going to get lower or closer to 0. And if they get worse, of course, the number is going to get higher. So I'm going to go ahead and raise the RPM. Again, we're going to want to hold it steady at 3,000 RPM. Only pay attention to these values whenever you're holding it steady. So as you can see, we're holding it steady. Well, looks like the traction control light and another light came on. Oh, and now we're in open loop status here, so we don't have any adjustment. Let me let off here. Our check engine light is flashing. You guys see that? Okay. Now it definitely feels like the engine is shaking. Let's see if this thing will go back into closed loop. There we go. So you can see, well, it went back into open loop. Check that out. It's kind of flip-flopping back and forth, open and closed. So it looks like the short-term fuel trim is pegged out right now. So it really can't even hold it in closed loop. See that? That's kind of weird. Okay, yeah. So it looks like we're back in closed loop. No, we're back in open again. Okay. That's interesting. It looks like at this point, the short-term fuel trim and the long-term fuel trim are both too high in order for this to stay in closed loop. So let me just try cycling the key off and then back on. Start this thing up. See if we can reset those values. As you can see, we're back into closed loop. So, okay, yeah, we're back to where we were before. So you can see we're somewhere around 23 on the long term. Again, I'm going to raise the RPM. I'm going to hold it maybe somewhere around 2,500 RPM. Just pay attention to these fuel trim values. I'm holding it at 2,500 RPM. Now, before it went into open loop, it looked like the fuel trims were actually getting better. So if you ask me, I mean, it looks like we may be chasing a vacuum leak. And if we are, I mean, I'm pretty sure that's got to be a pretty big vacuum leak. So let's go ahead and move under the hood and see if we can find anything obvious. All right, guys, so moving under the hood. Now, the first thing I noticed, and you guys might notice it also, is that right on the side of this air box, you see we have a hole right there. That's actually for the breather tube. Now, I don't know if this is where our problem is, but this is just the first and most obvious thing that I can see. And if you look down under here, you'll see the tube right there on the side of the valve cover. That's where the hose connects. There's a hose that runs from here up to this air intake box right here. And as you can see, it looks like the plastic nipple must have broken off. And so I don't even see any remnants of the hose or anything like that. So I don't know how long it's been driving like that. Now, we are going to have to fix that before we deliver it to the customer, but whether or not that's where our problem lies, I'm not really sure. I don't think so, because typically a breather hose does not create a vacuum leak. That's really for crankcase ventilation. So if I stick my finger into the hole for the nipple there, where the hose goes, it does not suck my finger in because that's not a vacuum supply. That's really just a vent for the crankcase. Now, I guess what we could do before we go any further is we could probably just try to find something to top off this little hole here. And we could probably recheck our fuel trim values. So let me see if I can find something to top that hole off with. All right, guys, so check this out. Got my kit for my smoke machine. Comes with a bunch of different plugs, so I think this one fits right into that hole. Just like that. Now let's move back inside, double check our fuel trims. All right, guys, so as you can see, we are in closed loop. I'm gonna go ahead and start raising the RPM, and let's pay attention to these fuel trim values. Let me see where I'm at. Let's get up to about 3,000 RPM here. right about there. And we're back into open loop. Damn, okay. Let me try that again. Let's let this thing idle down. See if we can get back into closed loop. Yeah, it does not want to stay in closed loop, so I'm gonna go ahead and shut the ignition off, turn it back on. Now we're back in closed loop. Let's let these fuel trims adjust. Okay, so as you can see, we're back up in the high 20s. I'm gonna go ahead and raise the RPM. Pay attention to these fuel trims. As you can see, we're going -20. And now we're back in open loop. So it definitely looks like the fuel trims are getting better just before it goes back into open loop. But what I can tell you right now is that I don't think putting that plug into that hole really did anything. At this point, I think the next thing I want to do is try to attack the purge valve. We need to take a look at it and see if it's stuck open. All right, guys, so moving under the hood. As you can see, I went ahead and I removed the air box. It's over here on the ground. And I also took the cover off for the valve cover. That way we can see everything that's underneath here. Now, if you take a look, what we're going to concentrate on is going to be the purge valve. It's located right here. And if you take a look at this purge valve, you'll see that we have two lines connected to it. This line right here and this line over here. Now, if you follow this line back, you'll see that it goes straight to the intake manifold. This means that this is going to have engine vacuum at all times while the engine is running. Now, if you take a look at the other side of the valve, this line right here is a line that goes back to the EVAP canister. Now, what we're going to try to do next is we are going to disconnect this line here, pull it off like that. Then we're going to unplug this solenoid, because of course this solenoid, when it's unplugged, should be in a normally closed position. Let me get my fingers in here, hot, like that. So now that we have the plug disconnected, I'm gonna go ahead and start the vehicle up. And when we start this vehicle up, of course, as long as this valve is not stuck open, we should not have vacuum on this side. So with that being said, let's go ahead and start this thing up. Okay, so I've got the key right here. I'm gonna go ahead and stick it into the ignition, start this thing up. Okay guys, so as you can see, we have the engine running. Now it's real important because we have the air box removed. The throttle body is completely exposed, so we wanna make sure that nothing falls into the throttle body. Now the other thing is that I think this bracket back here is loose because it's making a lot of noise. I'm gonna just touch it and hold on to it with my hand. As you can see, it quiet down. If I let go, that bracket is just shaking because it's loose. So hopefully this doesn't annoy you guys. Let me see if I can find something to hold this thing down. Okay, so sometimes you just gotta improvise. Much better. Okay, so now let's move back over to our solenoid over here. And again, what we want to do is we want to verify that we don't have vacuum on this side, because of course this purge valve is disconnected, so we should not have vacuum flow through this valve. I'm going to go ahead and stick my finger here. Now I don't know if you guys could tell, but we definitely still have vacuum on this line here. Just take a look at the way this thing is sucking my finger in. So it's pretty evident that we're gonna need to replace this purge valve. Now, whether or not that's causing the majority of our vacuum leak, we still need to verify that. And of course, I think the easiest way to verify that is just go ahead and plug off the end of that purge valve. Okay guys, so I found another one of these plugs. Just gonna go ahead and plug off the end of the purge valve. Now, let's go ahead and move back inside the vehicle, check out our fuel trims. Well, actually, before we do that, we're gonna have to reconnect or reattach this air box, because that's where the mass airflow sensor is located. So we're gonna have to reconnect all of this. Okay, so as you guys can see, I've got the air box reattached, mass airflow is reconnected. So let's go ahead and start this thing up, check our fuel trims. Okay, so we have our 3 data PIDs, the loop status, short term and long term. I'm gonna go ahead and start the vehicle up. Now let's pay attention to these fuel trims and see if they look any better. Okay guys, so as you can see, right off the bat, our fuel trims look way better. Looks like we shaved off about 10 points on the long term. Our short term is sitting somewhere around 0. Now let's go ahead and try to do the RPM test. Again, I'm going to go ahead and hold the RPM somewhere around 3,000 RPM. We're going to pay attention and see what happens with these fuel trims. Man, that's interesting. Why is that happening? Okay guys, so once again, it went back into open loop. And this thing just sounds like it's running like crap. And again, whenever that happens, it looks like the traction light comes on and the stability light comes on. And last time our check engine light was flashing. It's not doing that right now, but I'm not really sure what's going on. I'll take a look at our fuel trims here. Well, we're still in open loop. So I'm not sure why it was counting the short term there. Okay, so at this point, I think this thing is just really confused. Or maybe I'm just really confused. Let's go ahead and add the data pit for the mass airflow sensor. Okay, so we have the data pit up here for the mass airflow sensor. Let me go ahead and switch it over to grams per second. I know a lot of you guys, as well as myself, are more familiar with grams per second. So we're looking at 2.6 grams per second. And again, looking at our fuel trims, right now we're in closed loop and our fuel trim values look pretty good. Now I'm going to go ahead and raise the RPM again, see what happens. Well, our battery's getting low here. Close that out. Okay, so check that out. Around 2100 RPM. This thing went into open loop again. 3000 RPM. Okay guys, so at this point, I'm not really sure what's going on with this. Okay guys, so at this point, I'm wondering if we may be dealing with a problem with the camshaft actuator solenoid. Because again, as you guys remember, we had a leaking purge valve. We plugged it off. Our numbers definitely got better, because before the long term was sitting somewhere around 28. It was pretty much pegged out. Now, after plugging off that purge valve, you can see we shaved over 10 points on the fuel trim. So we can say without a doubt, this thing definitely needs a purge solenoid, but I don't think that's the complete fix. Now, if you guys remember, whenever we were reading the trouble codes, we understood that it was highly likely that we had multiple different problems stacked on top of each other. I think that's exactly what we're dealing with. And at this point, I think we've solved part of the problem, but I think the other part of the problem is going to have something to do with that intake camshaft actuator solenoid. Now, if you guys think about the actuator solenoid and what it does, its job is to adjust the camshaft timing based on the engine RPM. And what I'm seeing here is whenever we hit somewhere around 3000 RPM, we start having serious drivability issues. The engine starts running really rough. The computer goes into open loop and our check engine light starts flashing. So I've got a pretty strong gut feeling that more than likely we're dealing with the problem with that solenoid. Okay guys, so a real quick check that we can do if we suspect a bad timing solenoid. Using the scan tool, we can go into active test. And what you're going to want to look for is going to be the camshaft actuator. And in our case, we're dealing with the intake, so I'm going to click on intake camshaft actuator. Now, I've shown this test before in a previous video. I'll link that in the description, but the test is pretty simple. If you look here, it says make sure that it's in park or neutral, set the parking brake, block the drive wheels, start and idle the engine. The engine is idling right now at the moment, so let's go ahead and hit OK. Okay, so what we're going to do is we are going to use this active test to command the timing solenoid to come on. And if you look up here, you'll see that we're not commanding it at the moment. Down here, you'll see a button for increase or decrease. So what we're going to do is we're going to increase the duty cycle. And what we want to look at is the exhaust camshaft position. We want to see that it matches the desired camshaft angle data PID, and we want to see whether or not it follows it. So I'm going to go ahead and command it to increase the duty cycle. So again, I'm going to click on increase. You'll see 5 degrees on the commanded state. Now looking at the intake camshaft position angle, you'll see 5 degrees. I'm going to go ahead and increase it a little bit more. 10, you'll see it match 10. Now let's go up to 20, well 15. So there's 15, let's go up to 20. Now we're 20, you can see it's matching. I'm gonna go up to 25. So you can see it's matching. Now the only problem with this test is that you only have a limited amount of time to do it. It looks like we've been timed out. Yep, there we go. It says 30-second timer has expired. Not allowed to control for 60 seconds. So we have to wait a minute before we can actually do the test again. Okay, let's see if this thing will let us back in. And we're back in the active test. Now once again, I'm gonna go ahead and hit increase. We're going to watch the desired and the actual intake camshaft position angle. 5. Let's go ahead and jump up to 20. Now what I want to do is I want to go ahead and decrease it and see if this thing is not sticking. So I brought it back down to 0. And as you can see, our data PIDs went back down to 0. So according to this test, it looks like everything is working just fine. Now that doesn't mean that we don't have an intermittent problem. Typically with these camshaft timing solenoids, they tend to work fine most of the time. And then sometimes they'll just stop working because they start to stick. So just because we don't see a problem here doesn't mean that we don't have a bad solenoid. Okay guys, so moving back under the hood. Now the first thing that you want to check whenever you're dealing with the camshaft timing solenoid problem is you always want to check the oil level first. And I've already gone ahead and done that, but I'm going to go ahead and pull the dipstick just to show you guys. But the oil level is full. See if I can get a close up right there. Now it may need an oil change due to the condition of the oil, which, I mean, actually it doesn't look that bad. So anyways, we know it's not going to be a problem with the oil level. I'm going to go ahead and put this dipstick back in here. Now the next thing that you want to check is to see whether or not these solenoids look like they're the original ones. So if you take a look at these solenoids, you can tell they're pretty dirty. They look like they've never been replaced. So honestly, because these are so faulty or so prone to failure, it's actually not a bad idea to replace them just based on the fact that you've got a code for it and they've never been replaced before. So like I said, just looking at this thing, you can tell that that is the original equipment one. And if you look at the other one, which is the exhaust, so if you're looking at it from this side, you'll see this is the intake. It's labeled intake right here. And this other one over here is going to be for the exhaust. So we have two timing solenoids. The one we have a problem with right now is going to be the intake. Now, I would highly recommend to replace both of them. But since this customer's on a budget, we're probably just going to be replacing this one here. Now, the other thing we could do is take a look at the connector. Make sure that we don't have broken wiring harness or a broken connector. But looking at this connector, it looks like it's in pretty good shape. Let me try to unplug it. Okay, there we go. Okay, so taking a look at this connector, I mean, it looks like it's in pretty good shape. So I don't think we have a problem here. Now, what we could also do is just go ahead and remove it, take a look at it, see if maybe it's really gummed up. Okay, so taking a close look at the solenoid, as you can see here, the screen itself does not look like it's clogged, nor does it look like it's broken. But that doesn't mean that this solenoid can't still be sticking. Take a close look in there. You can see that the solenoid itself does not seem to have any obvious signs of being faulty. But now maybe another thing that we could do is probably do a resistance check using an ohm meter. We could probably take an ohm meter, touch those two pins, and check to see if we have excessive resistance inside of the solenoid, which I guess isn't really that difficult to do. So let me go ahead and get my ohm meter. Okay guys, so over here I have my Vantage Pro, and if you look over here, we have the timing solenoid. Now if you look, I have both of my leads attached to both of the pins, and if you look, we can see our resistance measurement is reading about 12.39 ohms of resistance. Now I believe that's actually right on the money. So to me, it looks like this solenoid passes a resistance measurement. So I mean, at this point, I'm not really sure what to tell you. I'm probably still going to recommend to the customer to replace the solenoid, because again, like I said, it could be an intermittent failure, and this does look like the original equipment solenoid. So I am going to recommend it just to CYA, you know, cover your ass or cover my ass. That's a phrase we use a lot in this industry. We know that we can do multiple tests, but at the end of the day, sometimes things just like to fail intermittently and they like to come back. So we don't want this thing to come back with any of the same issues. If it comes back, it needs to come back for a different issue. So like I said, I'm going to go ahead and recommend it to the customer, and we'll see what he says. All right, guys, so good news. I got approval to replace both the timing solenoid and the EVAP solenoid. And of course, we are going with AC Delco products. We are not using any aftermarket replacement parts when it comes to these things, especially the timing solenoid. I've seen people have a lot of bad luck using a specific brand that I won't name. In our case, so we don't have any problems, we're gonna stick with using the original equipment, AC Delco. So this is the timing solenoid. Let me open it up. And there we have our brand new part. Actually looks really nice and shiny. Okay, so I'm gonna go ahead and install these parts. Now, I did explain to the customer, and he does understand that what we're dealing with is multiple different problems. So this right here is going to be the beginning as far as the steps that are taken to repair this vehicle. So the customer does understand that we are replacing both of these parts, but this may not fix all of the problems that we're dealing with as far as the check engine light goes. Okay, so I've got the bolt tightened and the plug reconnected. Now let's go ahead and replace this EVAP solenoid. Okay, so we've got the new solenoid installed. As you can see, I have both lines connected and the electrical connector is reconnected. So now let's go ahead and put everything back together and start this thing up. Okay guys, so we're back inside the vehicle. Now, one quick thing I want to do before we try to start this thing up is I want to go ahead and erase all of the codes. We're going to clear the memory. That way we can start fresh. Now, if we go to special functions over here, there's going to be a fuel trim reset. So we're going to want to do this here. So we'll go ahead and hit reset and we are good to go. So let's go ahead and back out of this here. We can probably pull up some live data. Okay, so now at this point, let's go ahead and start the vehicle up. And let's see what happens with these fuel trim numbers. So far, everything looks okay. Let's just give it a few minutes to self-adjust. Well, I just saw something I didn't like. I saw it jump up to like 25. Did you guys see that? Okay, so it doesn't want to do it again. That's kind of strange because I don't know if you guys saw that, but for just a quick moment, it jumped up to 25. Then it came back down. And now looking at these fuel trim values, I mean, they look pretty decent. We're settling somewhere around 7 on the long term. And seems to be staying pretty close to 0 on the short term. There goes that 25 again. Did you guys see that? 10. This thing just keeps climbing up. It's kind of strange the way it's doing it too. I wonder what would happen if we raise the RPM. So again, taking a look here, I'm gonna go ahead and accelerate this thing. I'm gonna hold it somewhere around 2500 RPM. Take a look at those fuel trims. They're going really negative now. What is happening here? We're going negative, and then we just went into open loop there. As you can see, our check engine light is flashing again, and our traction control light came on, stability track light came on, and we're back to running like crap. Okay, so doesn't look like anything really changed at all. What the hell is happening? Okay, so one of the things I want to look at in particular is going to be the mass airflow sensor. So as you can see, I have it on a graphing mode. I'm looking at the mass airflow sensor grams per second. I'm just gonna go ahead and do a full screen on this so we can get a better view of it. Okay, so if you pay attention to the line on the graph down at the bottom, you can see it's pretty flat. If you look up here, you can see the actual number, 2.78 grams per second. So I'm gonna go ahead and snap the throttle. As you can see where our peak was, maybe somewhere around 50 or 60. I'm gonna go ahead and do that again. Okay, so as you guys can see, after doing a few different throttle blips, you can see we're peaking out somewhere around 70, close to 75. I don't see any type of glitches or dropouts in the signal, though I mean, we are looking at it from a scan tool, and of course the scan tool, you know, we're not gonna be able to see real fast glitches or dropouts in the signal. But as far as I'm concerned, everything here looks okay. I guess the next thing we could probably do is maybe take the mass airflow sensor out, do a visual check, make sure that there's nothing stuck inside of it. I mean, I've seen everything from bugs to leaves stuck inside a mass airflow sensor, so it's easy enough to take it out. Let's go ahead and move under the hood and check it out. All right, guys, so I went ahead and took the 2 bolts off of the mass airflow sensor. Now we can just pull it off and take a look inside. Now looking closely at this thing, I don't see anything trapped inside. I don't see any leaves, I don't see any bugs, I don't see any debris. And the actual filaments here look pretty clean, so if you take a close look at that, you'll see that they're not covered in any type of dirt or debris. The sensor actually looks like it's in pretty good shape. So, I mean, at this point, I don't think there's anything physically wrong with the sensor. Doesn't mean that we couldn't have a connectivity issue with the sensor, but at this point, I'm gonna go ahead and stick this thing back in, try to figure out what our next step is. Okay guys, so we're back at the scan tool. Now, before I installed that mass airflow sensor, I went ahead and I ran a cleaner through it. So I used some of that CRC mass airflow sensor cleaner, cleaned it out just to see if it made a difference. And after coming back to the scan tool, I can tell you right now that made absolutely no difference. Let me show you what I have up on the scan tool right now. So I added a couple data PIDs. What we're looking at here is going to be the upstream oxygen sensor, and over here we're looking at the downstream oxygen sensor. So I went ahead and I graphed those two just so we can look at them, and I want to see what the oxygen sensors are doing whenever this thing is reading rich. So pay attention to these. I'm going to go ahead and raise the RPM, watch those fuel trim values, and watch the oxygen sensor. Again, you can see how the oxygen sensor was switching over here, and you would expect the oxygen sensor to start switching faster, which it's kind of doing here. But as you can see, we just went into open loop here. Now we have a flat line on both upstream and downstream sensors. Again, we're in open loop. I just let off the throttle there, and again, this thing is running like crap. So take a look here at the instrument cluster. Again, our check engine light is flashing, so we definitely still have a problem here. Now, whether or not that tells us anything, I'm not really sure. I'm actually still trying to figure out what direction I want to go in. I feel like I may have to do a little bit of brainstorming to come up with whatever should be our next step. Okay guys, so after taking a quick break and doing a little bit of brainstorming off camera, which is something I think I need to do a little more often, because a lot of times when I'm working with the camera on, I'm just too focused on working the camera, making sure I have the shot right, and then trying to articulate my thought process so that it makes sense and it doesn't come out all scattered, which I kind of feel like this video is a little bit scattered at the moment. So I kind of want to clear up everything, make sure we're all on the same page. That way we understand how we've gotten to this point. So if you guys remember, at the beginning of the video, we had multiple codes, and we agreed on the fact that we may have multiple different problems. What I can tell you now is that we definitely had to replace the EVAP purge solenoid. We are 100% certain of that because we checked it, it was leaking, and after we replaced it, we did have an improvement in the fuel trim. Now, if you guys recall, we also had a code for the intake camshaft actuator timing solenoid. Now, I think we can all agree that it was probably a good idea to replace that solenoid anyway. If you guys have ever worked on these Ecotec engines, you'll know that it's a real common problem, and most of the time it's an intermittent failure. So personally, I don't feel that there was anything wrong with us replacing the solenoid. I think that took care of a second problem that the vehicle had. But now I feel like we're dealing with the third problem. And as you guys could see, our third problem is that whenever we reach about 3,000 RPM, our check engine light starts to flash, the traction control light comes on, the StabiliTrak control light comes on, the computer goes into open loop, and then it starts running like crap. So to me, I'm considering that to be a separate problem all by itself. And just to prove that to you guys, what I went ahead and did was I cleared the codes, cleared the memory, and what I want to do is I want to raise the RPM, get this check engine light to flash, and I want to see what code comes back. Because whatever code comes back first is going to be the code that tells us why that check engine light is flashing. Now, what I'm going to do is I'm going to accelerate the engine, and like I said, it's like clockwork. Once we hit around 3,000 RPM, this check engine light's going to start flashing. We'll see the lights come on over here. And then the first thing we're going to want to do is we're going to want to move over to the scan tool and check our codes. So I'm going to go ahead and accelerate the engine. Pay attention. Around 3,000 RPM. See that check engine light start flashing? These lights came on, and now it's doing some type of reduced power because I'm still holding the throttle in the same position, but it seems to have dropped down. And then I let off, and this thing is shaking and it's running like crap. So again, our check engine light is flashing. Let's go ahead and move over to the scan tool and see what code we have. Check that out. We have a PO300. Now, that actually kind of makes sense because usually when you see a check engine light flashing, that's a good indication of a misfire. Now, the big question here is, what type of misfire are we dealing with? And the problem is that we get a PO300, and that's not cylinder specific. That's just simply telling us that there's a misfire. And the other question is, what came first, the chicken or the egg? What I mean by that is, did the misfire happen as a result of the fuel trim values being screwed up, or were our fuel trim numbers a result of this misfire? That's going to be the question that we need to answer. Now, I suppose the other thing that we could do is, I believe there is a misfire counter in the scan tool. Let's see here. Okay, check this out. We have a misfire graphic. Now this one, if I'm not mistaken, it works a lot like the Fords do. Yep, there we go. So we have a line here, which is a line graph. And this is gonna work a lot like the Fords do, where whenever you see a misfire, you're gonna see a type of waveform, a triangular shape, that's going to indicate what cylinder we have a misfire in. So let's watch this and pay attention. If you look down here, you'll see this is cylinder number 1, this is cylinder number 3, cylinder number 4, and cylinder number 2. So I'm gonna go ahead and start raising the RPM, get it to around 3,000, which is where we're having a problem. Then we're gonna pay attention to this graph and see what happens. So I'm gonna go ahead and accelerate. Oh, check that out. We're at 2,500 RPM. We already see activity, mostly in cylinder number 3. Oh, yep. It just knocked me down. The check engine light is flashing again. So I didn't even have to make it to 3,000 RPM. It definitely looks like we have a misfire on cylinder number 3 and cylinder number 2. Though if you ask me, I think cylinder number 3 is really where the majority of it is. Okay, so at this point, I'm thinking that we should probably focus more on this misfire, because I'm starting to believe that this misfire is going to be the cause of our bad fuel trim numbers. And if you ask me, it kind of makes sense, because if you think about it, what if we have a leaky fuel injector? Maybe a fuel injector that's staying stuck open, and that fuel injector is just spraying fuel. It's causing a misfire on cylinder number 3, and you know we're seeing activity on cylinder number 2. But then on top of that, because that injector is spraying all the time, it's probably causing this thing to read rich, which is throwing it into open loop, causing this thing to run like crap. So I don't know, that's just a theory. I don't have any proof yet. I mean, it is still possible that we could have a faulty ignition coil or something like that, but I'm gonna go with my gut feeling. I'm gonna chase the fuel injector, maybe do a fuel injector balance test, and see if we can find out what's wrong with this thing. Okay guys, so we are set up to do an injector balance test. It's a pretty simple test to do, and the nice thing about it is that GM actually put a function into the scan tool so that we can do the injector balance test through the scan tool. So if you look over here, what I have is my fuel pressure gauge, and if you look, I have it connected to the fuel rail right over here. And what I'm going to do is I'm going to go into the fuel injector balance test over here using the scan tool. I'm going to click on that. Now you want to make sure that you're going to do this with a completely cold engine. You don't want to do this with a hot engine, because that's going to give you inconsistent measurements. So anyways, if you look back at the scan tool, if you look right here, you'll see that we have cylinders number 1, 2, 3, 4. These are going to be the fuel injectors. We're going to activate them one at a time. And whenever we activate an injector, it's going to prime the fuel pump. We're going to wait to see where the resting pressure is. Then the computer is going to activate the fuel injector. We're going to see how much pressure drops. And then we are going to compare that pressure drop between all of the fuel injectors. So let's go ahead and get started with number 1. I'm going to go ahead and click on it. Pay attention to the fuel gauge. You see it activate the fuel pump. Now it's going to activate the injector. And as you can see, we're somewhere around 38 PSI. So we're going to go ahead and do number 2. Again, it's going to prime the fuel pump, get to resting pressure, then it's going to activate the fuel injector. As you can see, 38 once again. Now we're going to go on to cylinder number 3. Pay attention to that gauge. There's our resting pressure. Just activated the fuel injector. You can see 38. And finally, cylinder number 4. Pay attention. It just activated the fuel injector. And 38 PSI. Okay, so according to this test, it looks like all of our fuel injectors are within specifications. Originally, we were thinking that we had a problem with the bad fuel injector, maybe a fuel injector that was stuck open, but according to this test, it looks like all of our fuel injectors are good. So at this point, we can move away from a fuel injector being a problem. We need to do a little bit of brainstorming, try to figure out what our next step is. Okay guys, so we've already determined that we don't have a problem with the fuel injectors. Next up, we need to try to figure out what type of problem do we have. Do we have a problem with maybe an ignition coil, or maybe a spark plug, or do we have a mechanical issue? Now when I say mechanical issue, I'm referring to something that may cause low compression or issues with volumetric efficiency. And so the next step that I want to do is a real quick crank it test. So what I'm going to do is I'm going to put my foot on the accelerator all the way to the floor. I'm going to crank the engine, and what that's going to do is that's going to crank the engine while disabling the fuel system. And while the engine is cranking, we're going to listen to the sound of the way the engine is cranking. If you pay attention to the way the engine cranks, there's a rhythm to it. You should hear a pretty even rhythm, something like a where each compression stroke is pretty even in rhythm. Now if we crank it over and we hear some irregular rhythms, something like a then there's probably a good chance that we have a compression problem. Now I know some of you guys might be laughing at my impressions, but I'm just trying to give you an idea for what type of sound we're looking for. So with that being said, I'm gonna go ahead and move inside the vehicle and crank it over. Now, hopefully you guys could hear that. It sounded like the engine had a pretty even rhythm to it. So if you ask me, I don't believe that we have a low compression problem. Now, this is in no way a definitive test, but it is a good preliminary test to do when trying to figure out what direction you want to go in. So next up, I want to go ahead and focus on these ignition coils and see if we might have a problem there. Okay guys, so moving over to the ignition coils. Now the first thing I noticed is that these are 4-wire coils. So what that means is that the transistor is built into the coil. What that also means is that we can't look at the secondary ignition waveform pattern, which would be really helpful in trying to determine what type of misfire we have. So that option is not available to us because of the design of the coil, but there are still a few different tests we could do. We could use a lab scope and do a current ramp test on all of the coils. But I think one of the first things I want to do is a very basic and simple test, and that is swapping over the coils. So if you look at the way this engine is laid out, this is a 4-cylinder engine, and the cylinder layout is going to be cylinder number 1, 2, 3, and 4. So as you can see, this coil over here, I put 3 dots on there using a little paint marker, and that's going to identify the number 3 coil. And what we're going to do is we are going to swap this over with the cylinder number 1 coil. Then we're going to start this thing up, hook up the scan tool, and check to see whether or not the misfire moved from cylinder number 3 to cylinder number 1. I'm just going to pull this coil out like so. Now the first thing you're going to fudge. Now the first thing you're going to want to do is inspect the coil, make sure that it's not covered in oil. As you can see, this one's pretty dry, and if you look down into the spark plug hole, it also looks pretty dry. So let's go ahead and pull the other coil out. We're going to do the same thing with this one. This also looks pretty dry, so let's go ahead and move this over to cylinder number 3. Grab the cylinder number 3 coil and put it into cylinder number 1. Now let's go ahead and start this thing up. Okay guys, so we are back inside the vehicle, and as you can see, I have the scan tool connected. We have the misfire graphic pulled up. I'm going to go ahead and raise the RPM, and let's pay attention to the graph. And as you can see, we still have a misfire. And that misfire is still on cylinders number 3 and number 2. So it really looks like nothing has changed. Okay guys, so let me show you the next test that I'm doing. We're going to be looking at the amperage of each of the coils. Let me show you the setup that I have. So I have my amp probe right here. And as you can see, I have this little fuse buddy where we were able to pull out the engine number 2 fuse, which is the fuse that feeds power to all 4 coils. And what's nice about this thing is that it allows us to clamp our amp clamp right on this piece of wire here. So now that we have that set up, let me show you what we have inside. So as you can see, we have the Snap-on Vantage Pro. I'm gonna go ahead and start the vehicle up. And if you look on the lab scope, you'll see we have our current ramps for our ignition coils. Now we can probably zoom in, try to get a little bit more detail. If you look, we have a nice current ramp. Now what I'm going to do is I'm going to back out. And as you can see, we have 2 coil events on the screen here. But I'm going to go ahead and accelerate the engine. Again, we're going to try to get it to around 3,000 RPM. We're going to pay attention to these current ramps and see what they look like. As you can see, as I'm accelerating the engine, the frequency of these coils firing, they're kind of coming together, filling up the screen. And if you look at the peak of each of the coils, we're somewhere around 7, maybe 7.5 amps, which looks about right. Now I'm going to go ahead and accelerate it. So you can see our check engine light started flashing, but our coil ramps all look really good. And now we're back to running really bad, really rough. As you can see, the check engine light is flashing. It's misfiring, but all of the current ramps for the coils look really good. Okay guys, so check this out. So my next step was to remove the spark plugs. First to inspect them, and then secondly to do a compression test if need be. But I think I may have found the problem. Let me show you guys. So as I was pulling the spark plugs out, I just kind of wanted to inspect them, see what they look like. I do remember the customer telling me that he recently had the spark plugs replaced. As you can see, these are brand new AC Delco spark plugs. Now they don't look like they're in bad shape. These are brand new spark plugs, but let me show you cylinder number 2. Whoops. Which is right here. And if you take a close look at this spark plug, it is cracked. Now, I don't know if I did this when I went to remove the spark plug, or whether or not this was done whenever the spark plugs were installed by the previous mechanic. But all I can tell you right now is that this definitely needs to get replaced. So I'm gonna go ahead and run to the auto parts store, get a new set of spark plugs, put them in, and see what happens. Okay guys, so I went ahead and picked up a brand new spark plug. This is an AC Delco. Of course, we want to put the original equipment stuff in there. Then also at the same time, I went ahead and I cleaned up the other 3 spark plugs. They were pretty much covered in anti-seize. So whoever did this job, I mean, really guys, there's no reason to use an excessive amount of anti-seize. Just a little bit of a drop on each of the threads is good enough. So I'm gonna go ahead and install these spark plugs, put everything back together, and let's see what happens. I guess the other thing I should mention before I put these coils back in is that cylinders number 2 and number 4 coils actually had some electrical tape wrapped around them. So I'm not really sure why that was done, but it looks like the previous mechanic did this. I'm wondering if they were trying to figure out why it was misfiring, and so they thought that maybe they had a bad coil boot and wrapped it in electrical tape. I'm not really sure, but we're just gonna go ahead and put these back in. Okay guys, so once again, we're back inside the vehicle. I've got the scan tool connected. We're looking at the misfire graphics, so I'm gonna go ahead and raise the RPM, see what happens. Up to 2,000, it looks pretty clean. Oh. Okay. There goes our check engine light again. And we still have a misfire. Okay, so that did absolutely nothing. What the hell? Okay guys, so obviously I'm pretty frustrated right now. I think I'm gonna go ahead and take another mental break. See if we can figure out what our next step is. I'm thinking that we might have a mechanical issue with the engine. That may be the next direction we wanna go in. So I'll be back. Now the other thing I also tried to do was swap over the coils for cylinder number 2 and cylinder number 4, because if you guys recall, those are the ones that had tape on the boots. I just wanted to make sure that that wasn't a factor. But even after swapping those coils over, we still have the same problem. Okay guys, so it's getting late and I'm running out of time, so I'm just gonna do a real quick compression check. I've got my compression gauge right here, and I'm gonna run down the line, do all 4 cylinders, and I'll share the results with you. Okay guys, so as you can see on the last cylinder, we have about 70 PSI worth of pressure. Cylinder number 1 had about 90. Cylinders number 2, 3, and 4 all had about 70 PSI. So if you ask me, it seems like it has low compression all across the board here. I think we should definitely be chasing a timing problem. So that's the direction we're gonna wanna go in. Okay guys, let me apologize for skipping ahead. It's getting late, it's starting to get dark, so I just wanna do what I can before the sun goes down. So anyways, as you can see, I have my lab scope over here. I went ahead and I did a cam to cam correlation. So you can see I have my channel 1 lead right here on the intake cam sensor, and then my channel 2 on the exhaust cam sensor back there. Now, I do still need to do the crank sensor, but the crank sensor is a little more difficult to get to. And like I said, I'm running out of time. So the quickest and easiest check that I could do right now is just comparing both of the cams, intake and exhaust, matching them up to see whether or not we have a timing problem. So now that we have the waveform captured, I'm gonna go inside and I'm gonna try to find a known good waveform that we can compare it to. Okay guys, so looking at a known good waveform, if you look over here, we have our intake cam and our exhaust cam. And as you can see, the pattern is they pretty much almost match each other. but they're just a little bit offset. So if you look at where we have this skinny pulse along with the kind of wide pulse, then if you see over here, we have the skinny pulse and then the wide pulse. And so what we're going to do is we're going to use the end of this wide pulse right here. And as you can see, it goes right through the middle of the wide pulse for the exhaust cam sensor. That's how we're going to compare the cam to cam timing. So if you look over here on the lab scope, that's exactly what we're showing. So if you pay attention to right here, we have our thin pulse and then we have our wide pulse right here. And then as you can see right down the middle, it cuts right through the wide pulse of the exhaust cam. So just by looking at that waveform, comparing the two, I can tell you right now that the cam to cam timing is correct. Hopefully that makes sense to you guys. Hopefully I explained it well enough. Now the next thing I need to do is we need to go over to the crank sensor and we need to compare the intake cam sensor with the crank sensor. So I'm gonna go ahead and try to get that waveform and I'll be right back. Okay guys, so I went ahead and I got the crank sensor signal. So as you can see up here at the top, we have our crank sensor signal, and down here we have our intake camshaft signal. Now if you pay attention to the known good waveform over here, so you can see our crank sensor signal has these notches, and if you pay attention to this notch right here, you'll see that it lines up with the second wide pulse of the intake cam sensor. So again, if you pay attention, we have a thin pulse, a wide pulse, and then the second wide pulse right here. You see the edge of that second wide pulse? That's where that notch is for the crank sensor. So if we look at our lab scope here, you'll see that we have the thin pulse here, and then we have our first wide pulse, and then our second wide pulse. As you can see, we have that notch for the crank sensor signal right where it needs to be. So it looks to me like we don't have a timing problem. Everything seems to be lining up properly. So at this point, I'm not really sure where to go with this. I'm gonna have to do a little bit more brainstorming and probably just continue this tomorrow. Okay guys, welcome back. It is the following day. I apologize about yesterday. I feel like I was having an off day. I really couldn't focus, and that's why the video might seem like it was a little bit scattered at the beginning. But anyway, today is a new day. It actually feels pretty good outside. It's a little bit windy, so I apologize if the wind is making noise. But anyway, back to the problem that we have at hand. Of course, yesterday we did a cam and crank correlation and we found out that we did not have a timing problem. Now today, the next thing I want to do is a cylinder leak down test, because of course, even though we know we don't have a timing problem, that doesn't mean that we can't have a problem with maybe a bad valve seat or a bad valve spring. Those things need to be taken into consideration. And so I think the next best test to do is a cylinder leak down test. We already have the spark plugs out. So you can see I have my leak down gauge here. And if you look in the cylinder number 1 spark plug hole, I have a long screwdriver. And the reason I have a screwdriver in the cylinder is to measure the cylinder top dead center. And so what I have on the crank pulley is a ratchet that I use to turn the engine over. And while we're turning the engine over, we're watching the screwdriver and we're waiting for it to hit the peak of its height. And that's when we know we are on top dead center. Now, of course, you always want to make sure that you're on top dead center compression stroke. The way I verified it was using a compression gauge. I basically had it hooked up to the spark plug hole, and as I was turning the engine over with the ratchet, I looked for a small pulse of positive pressure, and that's how I knew that I was on the compression stroke. So anyways, now that we know that we're on cylinder number 1 TDC compression stroke, I'm gonna go ahead and pull the screwdriver out. Now I'm gonna go ahead and take this hose and I'm going to thread it into the spark plug hole. Okay, so over here we have the leak down gauge. Now I'm gonna go ahead and hook up compressed air to it. And if you look, you'll see that our needle is on set. Now I'm gonna go ahead and take this end of the leak down tester and connect it to that hose. Okay, so as you guys can see, cylinder number 1, it's on the high end of moderate, really close to having low cylinder leak down. So we can now say with certainty that this cylinder is in good condition. Let's go ahead and move on to the next ones. So at this point, I don't see any evidence of a bad valve seal. The cylinder leak down test looked good all across the board. Okay guys, so let me show you where I'm at. I went ahead and I put everything back together just so I can get the engine running. And as you can see, I have a hose right here connected to an old school vacuum gauge. Now the reason I want to read the engine vacuum is because I want to verify whether or not we have maybe a floating valve issue. You know, it's a possibility that during high RPM we might have a valve that's floating due to a weak valve spring. And if that's the case, what you're going to see on this gauge is that the needle is going to bounce or vibrate a lot. And the reason for that is because the valve spring during high RPMs is not able to fully seat the valve because the spring itself has become weakened and it can no longer spring back the way it used to. So anyways, now that we have that connected, I'm gonna go ahead, move inside the vehicle and start this thing up. And as you can see, we're idling pretty smooth. I'm gonna go ahead and grab the gauge here. Okay, now if you pay attention to this gauge, you can see while the engine is running, the needle is in this green area right here where it says normal motor. That's a vacuum reading of somewhere between 18 and 22 inches of mercury, which is our vacuum reading. So I'm gonna go ahead and accelerate the engine and pay attention to this gauge over here. Okay, right there, hopefully you guys can see both. I'm gonna go ahead and accelerate the engine. Pay attention to that needle. So you can see it's got pretty good engine vacuum going up to 2000 RPM. The needle looks pretty smooth. Let's try to get up to 2500 RPM. Needle is still pretty smooth. Let's get up to 3000. And as you can see, our check engine light just started flashing. We're misfiring and the vacuum gauge looks normal. Now it's back to running like crap. Now, as you can see, again, during idle, we have a normal engine vacuum. So, okay, at this point, I don't think we have a mechanical issue. Maybe I just need to step back and try to figure out where I went wrong, because obviously I'm on the wrong path here and I'm starting to question whether or not I even know what the hell I'm doing here. Now, the other thing that I had in mind was, if we are having some type of fuel trim miscalculation error, is it possible that unplugging the mass airflow sensor and seeing whether or not it still misfires will tell us anything? So I think that might be my next step. I'm just gonna go ahead and unplug the mass airflow sensor and see how this thing reacts. Okay, so moving back under the hood, I'm gonna go ahead and disconnect the mass airflow sensor. And let's go ahead and start this thing up. Okay, so we're inside the vehicle. I'm gonna go ahead and start it up. We'll let this thing idle down for a second. I'm gonna go ahead and click on the misfire graphic on the scan tool. And as you can see, we have our misfire graphic pulled up. Now we're gonna go ahead, raise the RPM and see what happens. We're at 2000 RPM, 2500 RPM, 3000 RPM. Check that out. We're at 3000 RPM and we have no misfires. Let's go up to 3500 RPM. Maybe even hit 4000. Now I'm gonna let off. And as you guys can see, we have no misfires. So what does that tell us? That tells us that this definitely is more of a fuel miscalculation problem. And what I mean by that, the misfire was due to the computer cutting back the fuel, not the other way around. Now, as far as the possibilities, we still could potentially be looking at a bad mass airflow sensor, or maybe even a bad oxygen sensor, or maybe even an exhaust leak. It's possible that we could have oxygen getting into the exhaust system and it's throwing off our O2 reading. Okay guys, once again, let me apologize for skipping ahead here. The problem has been resolved. I believe the vehicle is fixed. Now, before I get into details of how I did that, let me just express to you guys the level of frustration that I've had for the past 2 days with this vehicle. Now, when I tell you guys that I was frustrated, I mean, I got to the point that I really didn't think that I knew what the hell I was doing. I mean, I was just done. I thought maybe it was time for me to start thinking about a different career, because obviously I just don't know what the hell I'm doing. Because when I tell you I checked everything, I mean, I feel like I've checked everything, and it got to the point to where I even went ahead and bought another mass airflow sensor just to try it out. I put the mass airflow sensor in there. It did not change anything. Now, luckily, I was able to return the mass airflow sensor with no problem, but still, I'm so ashamed that it came to that point. Anyways, so just as I was about to give up on this vehicle, and I mean, I had just gotten off the phone with the customer, and I told him, look, man, if I can't figure anything out within the next hour, you know, come pick up the vehicle, and we're just gonna have to try it, you know, at another time. So I hung up with the customer, and just as I hung up with the customer, a buddy of mine gives me a call. Now, some of you guys might know this guy, Oz from Oz Mechanics. If you don't, I'm gonna put a link in the description for his channel. You guys definitely need to check it out. If you haven't already subscribed to his channel, do that now. You won't regret it. Anyway, so Oz gives me a call just to talk about stuff. I mean, Nothing really related to this vehicle or anything like that. But during that phone call, I decided to express to him my frustration and this vehicle, and we were able to brainstorm together to try to figure out what might be happening with this vehicle. I explained it to him, everything that I checked, and how I still wasn't able to resolve the problem. And then he said to me, try to do a cam and crank relearn. And I thought, well, that's probably a good idea. Maybe I should try it. I mean, it's simple enough to do on the scan tool. So I did it, and lo and behold, I think it fixed the problem. Okay guys, so back over to the scan tool. I just want to show you real quick, if we go into special functions over here, and if you look right here in the center, there's a crankshaft position CKP variation learn. If you click here and follow the instructions, the computer is going to relearn the cam and crank correlation. Now, I've already done this, so I'm going to go ahead and back out and show you guys the result. So if we come over here, we'll back out one more time. Let's go to active test. And if we go to our Misfire graphic, I'm going to pull this up. Okay, now just like before, I'm going to go ahead and start the vehicle up. I'm going to go ahead and start raising the RPM. Let's bring it up. There's 2,000, 2,500 RPM. And now we're about to hit 3,000 RPM. Let's get up to 3,500 RPM. Let's go to 4,000. Now I'm going to let off. And as you guys can see, we no longer have a misfire. I mean, this to me is just, it's crazy. How did I miss this? Anyways, guys, at this point, I'm going to go ahead and end off the video. Once again, I want to give a big shout out to my buddy Oz from Oz Mechanics. Thank you for helping me fix this vehicle. That cam and crank relearn seems to have fixed the problem. Now, on a side note, I did take the vehicle for a test drive to make sure that the check engine light wouldn't come back on. And so far, everything seems to be working properly. Now, as to why the computer needed to have the cam and crank relearned, I'm not really sure. I don't know what could have thrown it off. I double checked the crank sensor and the cam sensor. They all seem to be operating normally. I put the lab scope on them. I didn't find any glitches or any dropouts. I made sure to wiggle the harnesses. I didn't find any problems there. I mean, it is possible that there could be some type of mechanical issue throwing the cam and crank correlation off, but at this point, everything seems to be working fine. Anyways, like I always say, thank you for watching the video. I hope you found it useful. I hope you found it educational. If you did, make sure to give it a thumbs up. If you haven't done so already, please subscribe to the channel. Make sure you hit that notification bell, and I'll see you guys in the next one. Thanks.